Questions from homework stuff? Well, maybe you'll work better without that. No. Any questions from homework stuff?
I wonder if maybe you could do one of them. I believe it's in... You told me here somewhere. It was just modeling.
Man, dude. All right.
I wasn't quite sure how to model one of these, other than just like writing.
So which problem was it exactly? Do you remember? Was it in chapter 2? No.
You know what?
Was it a 41 minus 29 thing again? Or no.
I'm not quite sure. I didn't actually write that.
It looks like it is. Oh, like this. Yeah. So if I said model 4 times 5, then that doesn't mean you put 4 times 5. I don't know how that helps me do anything.
Yeah.
Ooh, you made 4 matchsticks. So the idea of 4 times 5 is that you have 4 groups of 5, right? That's the basic idea of multiplication. So you would make a group of 5, another, and then you make 4 groups of 5. And that's why it makes 20, because 4 groups of 5 makes 20. I like it. So again, I understand that that is a very basic idea, and some of us might feel, well, but some of us need to start there to get back into the swing of things, right? Yes?
Question 99 on section 2.2.
You can ask any homework question you want. 99? The one about the like terms? Okay. So let's see. 99. All right, so this problem here says find all the like terms in there. Tell me all the groups of like terms from that problem. So are there any like terms with this guy? Yeah, what would they have to be like terms with this? They'd have to be something that has an A. Nobody else has just an A in it, right? Is that cool? You guys cool with that? So this is not a solving problem. This is just identifying problem. Is there anybody that's like terms with him? Oh, what about him?
Yeah.
Yes, cool. I got 16 ABs, 4 ABs. So if you want, you can just do like this. Bam, those go together. What about this? B squares, and there's more B squares. So those go together. There's your like term pairs. That's all I wanted was tell me which ones of these pair up like terms.
And it's okay for us to do it just like that?
Yeah, that's fine. Yeah. It didn't say to actually combine them. It didn't say. It just said identify them. Okay. How are you guys doing? Is everybody comfortable with the idea of like terms? And it's okay to not be. It's just not okay to not be and to not say it. Right? Here. They give you one problem that's not too evil, and then another problem that's a little more evil. This one might be a little bit evil, but oh well. I couldn't stop myself. I'm a math teacher after all. So one way you can do this, and the way I kind of do this really quickly, is I don't like to move stuff around. But if you want to rewrite it and move things around, that's beautiful. I'd rather go, is there any like terms with that? Now tell me this real quick. How many A's does this term have in it? How many A's does it have?
7.
No, there's 7. 7 groups where each one has an A. And how many Y's? 2 Y's. So to be like terms, you have to be exactly the same. They have to have the same letters and the same amount of each letter. Yeah, so these definitely go together. What about this one?
No.
Why not this one? Because this one has 2 A's and 1 Y. Now, Some of you guys, I don't know, some of you guys might feel like that's so picky. But I cannot. I can say I got 7 AY squares minus 8 AY squares. I can then figure out how many AY squares I've got. I can put those together.
Oh, that's different. Okay.
But this, how would that fit in? That's a whole other thing. That's 5 A squared Y's. That's a different thing. I can't consolidate it. So on one level, we do that in real life. You're not going to look in the next room. Can you tell me how many puppies and cats? You say 5 puppies, 6 cats. So 11 puppy cats. What? What just happened in there? Freaky genetic experiments. Puppy cat. I don't know. Cat, dog, maybe? No. Okay. Any other like terms? What about this dude? There's no more Y squares, right? I like it. So there's only these two. And who knows what 7 something minus 8 something? Negative one of them. I like it. You got $7 and you owe me $8. You're still going to owe me $1 after you pay off that 7. So this will be negative AY squared. And then these just stay the same. Bam. Alright, now I warned you this next one. I said it was going to be a little bit evil. Let's see what you guys think. Some people think it's evil. We'll see what you guys think. So let me just point this out. Which one of these is obviously the odd guy out? Poor little dude. He's got nobody to dance with. Yeah.
2.
Right? Anybody else? Yeah, maybe the 2. What's like terms with this?
2
AM.
Yeah, 2 a.m. But why would you say that not him? Why would you say not him? No. How many A's is supposed to have 1? How many M's? 1.
Oh, that is rude.
Yeah. Now watch. What's 2 times 7?
14.
What's 7 times 2? So what's A times M? It's the same thing as M times A. So somebody, me, wrote that out of order. So then put it back in order, right? So we normally put the variables in alphabetical order. They don't have to be, but we normally like to do that, right? So this one here is like terms, especially you can see that if I just turn those around. Does everybody see that? I mean, A times M is M times A, right? If you don't believe that, give me a number, 2 numbers that don't work like that. 3 times 5 is 5 times 3. They're the same. Please don't look for any, because you're not going to find any, right? If you do, you gotta let me know. That'd be like Nirvana. We'll both just instantly disappear in a puff of energy. Poof! Because you can't find it. So what do you get? 6 of them, plus 7 of them, plus 2 of them. 15. Yeah, 15 of minus 5a. And make sure you get it. 15a. So this, and this can be consolidated to this. Minus that poor little leftover dude. Yes?
Would that happen in like any of our problems? They try
It
to
could.
do that?
I can't remember specifically if they do that here, but it could happen to you anytime in your math career. Yeah.
So that could only be done when it's like letter to count. Like those numbers right there, like AY.
Yeah, if I turn this around, it's not going to suddenly make it the same as this. It would just be YA squared. It still ain't the same as AY squared, right? Does that make sense? All right, maybe.
That's a little different.
That one doesn't make sense for me.
Which one?
Yeah, that's a little
The
different.
AY
This
squared
one?
and then YA squared.
What's up?
Squared's only connected to the one it's next to.
Now be careful. I really want this. When I write A squared Y, what does A squared mean?
2A.
So it'd be A times Y. Right? I normally wouldn't write like this because I want to consolidate it, but just to pull it apart. So then if I turn stuff around, could I write Y times A times A? Isn't that the same thing?
Yeah.
So isn't that Y times A squared? Isn't that just that turned around?
So that doesn't.
Oh, I see.
But then it doesn't become like terms with this? Still, how many A's is it supposed to have? 1. How many A's does this guy have? He's still got 2. Just because you put the 2 A's over here doesn't suddenly make it match up with this guy who only has 1 A. Do you guys see that? So I wish to God everybody could understand. This is just you can only consolidate the things that are the same. You got so many of these, so many of the same things, so I can put those together. Those aren't the same things. You can't put those together. Cool. No matter how you rearrange the letters, they won't become the same thing magically, right? So let me see, real quick. Are these like terms here?
No.
No.
Think. What are you asking yourself? How many Y's does this guy have?
One.
Oh, yeah.
This guy has 1 Y. He's got. This guy has 3 X's. This guy. So in general, if they give you anything that's out of alphabetical order, the first thing you probably should do is put it in alphabetical order. So these 3 X's go first. Now it's really in your face that they're like terms, right? So then how many whats do I have here? 5 whats?
X is 3, Y.
Yeah, 5 X cubed Y's. I got 7 X cubed Y's minus 2 X cubed Y's, so I got 5 X cubed Y's.
So that would be the answer.
That would be it.
So if you see a problem with that, you would just put
Yeah, just make sure it's in alphabetical order, so then it's a lot more obvious if they're like terms. I like it. Maybe, maybe, maybe. So that's the slight evil thing that can happen, is if they're not in the same order, it can be tricky. I like it. So are these like terms?
No.
Why not?
B1, B2.
This only has 1 B. This one has 2. I don't care how you turn the damn thing around, they ain't going to match up. Yeah, the square's in the other place, right? I have more of the other letter. I can't consolidate those. Okay, maybe.
I have a question for you.
Sure.
On in 2.3 on number 162. I wasn't sure exactly how that went.
Oh, okay. Yeah, I like these problems actually, but they are a little weird to get used to.
Yeah.
So what this kind of problem it says, so it has this thing going on here. As an envelope, there's an envelope. Is that cool? Don't push my drawing skills, because they ain't there, so you can't. And it's got 1, 2, 3, 4, 5 of these, right? Yes. Then it's got here 1, 2, 3, 4, 5, 6, 7, 8, 9. I like it. So the reason I like this is it's kind of a very real world kind of thing. There's an envelope that I'm not allowed to open, but it's got a certain number of these gold coins in it. And I want to know how many gold coins it has. And I happen to know that on a balance, the envelope plus these gold coins is the same as these. Right? And let's say the envelope itself, the weight is like almost nothing. I always have some students. One time, you ever had a problem where you had to cut a piece of wood and then you have to say one is twice the length of the other one? And I had a carpenter in the class and he said, whenever you cut a piece of wood, you lose about a 1/4 inch of wood in the teeth of the saw. I'm like, all right, you can set up your equation with that. The rest of us are going to use lasers to cut the damn thing. Right? But I understand that. I mean, math is ideal, and then you adjust it for your specific real world conditions. So anyway, let's pretend like the envelope doesn't weigh shit. Right? So I'm saying that this envelope plus these coins equals the same weight as those coins. So what would the equation be? Well, how many gold coins are in this envelope?
5.
Well, do we know? Not yet. Right? So how many are in there? Beautiful. See, that's the point where students look at me like, I just told you, I don't know. What the hell? But we're in algebra. And the power of algebra is I can give it a name so I can do shit with it. I can't do shit with empty space. But if I say, I don't know what it is, X, now I can do stuff with it. So that's X plus 5 equals 9. And then you could solve it if they want you to solve it. I can't remember. And then solve, yeah. How would I solve that equation? Yeah. Subtract 5. Good.
5.
So you get X equals 4. There must be 4 gold coins in that envelope. Now there are real life situations that are sort of related to this. You don't know what this thing is, but you can compare it to a known thing and you can see what's going on. I mean, that kind of thing happens all the time. Yes?
In 2.3, can you do 180?
Is everybody cool with that problem there? You're going to see some of those problems every now and again.
I guess it's supposed to just come out how you got the numbers, how you just kind of, figured that part out and just put them down there. I mean, I can see, there's 5 and there's 9, but...
So how many are in the envelope?
Well, not because that's how I won't be able to...
No. How many are in there? I don't know.
Oh, 4. Okay.
Well, we don't know it first.
Right.
So
Okay.
we'd say the amount of coins in there plus these equals the amount on that side.
Yeah, see, when I was trying to figure it out, I was just like, okay, well, E4... And then I didn't know what to go from there. Obviously, I used E as envelope, but then
Oh, I
didn't
see.
know how I could
Cool.
make that.
I love it. That's beautiful. You could use E for the variable, right? I mean, X is the variable. There's nothing special about that. We just, some point in history, they said, what do we use for the
I was just
variable?
trying to figure out how you figured that out. Like, how you put that down on the paper. Like, I can see there's 4 and I can see there's 9, but how did you just put that into a format? Like, I couldn't figure that part out.
So let me ask you this. All right. Let me say, there's a room. There's a room somewhere. And inside there's some kids. I have no idea how many kids are in there because I'm a horrible caretaker.
Okay.
So how many kids are in there? You're in algebra, so we know. How many kids are in there? X. There's currently X.
Right.
You with me?
Any number, yeah.
Now, I see 3 kids come out. Yay, we come out. Yay, get me out of here. It's weird shit, man. So 3 kids come out. And I know that, and then somebody tells me now there's 10 kids in there. Let me see if you guys can do this. So there were X. 3 kids left.
Minus.
Good. So they lost 3 kids.
7.
There were X. It lost 3 kids.
7
And
equals 10.
equals 10. Careful now. You got to stop your brain. Your brain is going to want to go, I know what to do with 10 and negative 3. Yeah, shit. But then you got to go, brain, I don't know yet. It ain't 10 minus 3. How do you solve this? Add 3.
Plus 3.
Yeah.
Plus 3 and plus 3.
So you get X equals
13.
13. So there must have been 13 kids in the beginning. Now, I understand that if you're not saying to yourself, why do I need an equation for that shit? I could figure out there's 13 kids. If there's some kids and 3 leave and now there's 10, there must have been freaking 13, Jeff. Yes. But we are starting the idea of equations with situations that you should already know what the answer is going to be. So then you can get used to how algebra works. Because when you get the right answer, you're like, oh, I must have done the right thing. Right? I mean, we always want to start with a situation that's easy. And you're going to use a new idea to do it. To get used to the new idea. Because this is not going to remain this easy. So you want to get used to how it works now. Yeah?
Can I do that another way?
Well, how? Yeah.
Because X is 10, 3, the minus different. We'll do that.
Say it again.
I don't speak English with this. I can see you.
As long as did you use a variable in there
Yes.
in an appropriate way, then I'm okay.
With 2 numbers, we'll take it with them. And what is this? The minus will do positive.
Show it.
Can I show you?
Sure, come on.
Any number will X. If you minus any number, like 4. How many? 12? Any number. This. Can you do this? 12? This minus 4? 60.
Oh, you're just talking about solving it
Yes,
differently. You're just talking about solving it
Change.
differently.
Only
Okay,
this.
I'm with you. All right.
It's
all right.
easy.
All right, 2 things. Isn't that what we did?
Yeah.
Okay. Also, the thing that you got to get used to. So again, I know that a lot of these simple equations, a lot of you guys will be able to just do it in your head. I understand. You are getting used to the format of how equations work, so that when the equations get worse, you're able to keep track of everything. So I'm saying that, yes, that's the right answer. Sort of. The answer is X equals 16.
16.
Right? And I want my work to do that for me. So when you start trying to do things on the side and then bring other things back in, trust me, you're going to work against yourself. It's going to make more sense when we start getting more complicated equations, because then you want to be really, really careful with everything so that it comes out in the end. I like it. So right now, there's a lot of different ways to think about these equations. I desperately want you guys to get used to it. And I know some of you guys do it like this. Some of you guys do it all in the same line. Right?
Yeah. Same though.
Which I sort of wish teachers would stop teaching that, because it's kind of hidden what you did. Here I can see exactly what I did. I know exactly what I did, so I know if I forgot to do it on one side. Here it's all kind of like on one line. It's easy for it to get lost, especially when there's more stuff here to begin with. Right? But if this works for you, I'm not going to take that away from you. So but this will work too. But do you see how I got all the parts all coming with me? That, trust me, I'm trying to force you to do something that'll be nice to yourself for later, when the equations get a little worse.
Well, this is the way easy.
But what's different between this and this? What would I do? What would I do to solve this? I would do this. You ready? I would add 4. Oh, crap. Right? Isn't that what you did?
Yeah.
Okay, same. But you're actually using
What are you using?
what's here. Cool. I like it. I like it. Okay. Anything else from homework stuff?
Yeah.
Yeah.
On section 2.2, can you explain like 138 and 141? Pretty similar to their word problems, but
Oh, good. Yeah, good.
138.
All right. Well, let's look at 138. So Eric's got rock and classical CDs in his car. The number of rock CDs is 3 more than the number of classical CDs. Now, I wish they would have put that sentence after this next sentence. C is the number of classical CDs. So how many classical CDs does he have?
Oh, yeah.
C. And so all we're doing here is, sort of like you did earlier with the E instead of the X. E means envelope. Very often when you make your own equations, you can use letters that represent the ideas.
I can never just get the sentence into a format. I can do the format, I just can't get the one to the other.
So if I said, like, I ate 4 more hot dogs, and you could say H plus 4, I mean, you
Yeah.
can use a letter that makes sense physically.
Yeah.
So here they're doing that idea. They're saying, okay, there's C. The number of classical CDs is C. So C is just like X. It's just a number that I don't know yet. But I do know that there are 3 more rock CDs. The rock CDs is 3 more than that. So what does 3 more than something mean? What operation is that? Addition. So what do you do to C to get 3 more than that? Yeah, there's not C. They're not an equal amount. There are 3 more rock CDs. So I love those I just got. Let's say that Fred makes twice as much as Bob does, right? And I'm going to tell you, Bob makes B dollars. Bob makes B dollars. That's good. Bob B. I love it. So how much does Fred make?
2 times.
2 times B. And here's where, and I totally, now stay with me. Stay with me. I know a lot of you guys are like, here we go, we're going to get with this bullshit algebra. If I knew Bob's salary, wouldn't I just double it to figure out Fred's? Mm-hmm. So algebra is an attempt to generalize what I have to do. If I knew if I told you there's 3 more rock CDs up here, right? And I say 3 more rock CDs in classical. There's 5 classical CDs. How many rock CDs are there? 8. I mean, that we just know if there's 3 more rock CDs and there's 5 classical, there must be 8. Isn't that what this would say? 5 plus 3 is 8?
Yeah.
So algebra is an attempt to generalize what you do once you actually know what this number is. So if I know that Fred makes twice as much as Bob, then if Bob, whatever Bob is, Fred's going to be twice that. So now, specifically, if I found out Bob makes $1,500 a week, Fred must make $3,000 a week, right? I love it. So, but what algebra wants to be able to do is to represent those quantities without actually knowing what either one is. But haven't I captured the relationship between them? Whatever this is twice that. Whatever this is 3 more than that. It wants to capture that relationship between the two. And when I don't even know how many there are of each. But at least I know the relationship between them. And that happens more often than you would realize. We know the relationship, we just don't know how much of each there is.
So that's how they want it written down, C plus 3?
That's it.
Then it comes in the
And that represents the number of rock CDs. I love it. And then if you found out how many classical CDs there were, you could figure out how many rock CDs there must be. Yeah. Yes?
I have a question on 2.2 on number 114.
Oh, okay. I always wonder if my class got together and said, let's just ask him every homework problem and homework will be done. So maybe I'll just do a couple more after this.
We haven't got 2.4 yet.
Exactly.
That's next question.
2.2.
Now, when you first glance at this, what are the like terms in here? What's going to go with the 7C?
6C.
6C?
9C.
9C. I like it. And the rest of these, are they like terms with each others? With each others? Good job, Jeff. Good thing I don't teach English. Right? Just pure numbers are going to be like terms with each other. We already know that. So what's 7C plus 6C plus 9C? That's 13 plus 9? 22. Now what's 4 minus 3?
1.
Minus 1?
0.
0.
Okay.
Don't even write it. So if you wrote plus 0, you're technically not wrong, but why would you do that?
Can we go back to the 141 too? It's the same as 138.
Yeah, that's why I'm not going to do it. So now you guys, I got to leave something for you guys to try. Yes?
It's on 2.3. 195, it says twice the difference.
Oh, yeah, good. All right. You ready? Here we go. What is that in English? What is that in English? Twice a number. Is that cool? That's twice a number. Now, how do I write the difference between a number x and 5? How would I write that?
Negative.
Exactly. No, be careful. That would be the product of negative 5 and x.
32x minus 5?
No. These are two different things.
X minus 5. X minus
This is 1, there's 2. The difference between a number x and 5. It would be x minus 5. Is that cool? I think you guys thought it was going to be some trick question or something.
Yeah.
The difference between a number x and 5 is x minus 5. So, why is this twice a number? Because what's a number? X.
We don't know.
Yeah, we don't know, so we call it x. Or actually, you can call it n or whatever the hell you want. So what's twice that thing I just wrote down to it? You with me? No. Squared would be, they'd have to actually say squared. Twice means 2 times as much, right? Not squared. Squared is entirely different. So now I want to know what's twice the difference between a number and 5. So what's the difference between a number and 5? X minus 5. And now I want twice that.
X minus 10.
You went one step too far. So twice this would just be twice that. That is twice the difference of a number and 5. Because what am I doubling? I'm doubling the difference. So how would I say this? How do you say this? What's the difference there? That is 5 less than twice the number. This is not twice the difference. What am I doubling in this statement? What am I doubling? X. I'm not doubling the difference. Do you see the difference? between those? So if I said 4 times the sum, 4 times the sum of a number and 7. So what is the sum of a number and 7? What is that by itself? The sum of a number and 7. N plus 7. Kick ass. Now I want 4 times that.
Parentheses.
Why do I need the parentheses? Because if I do this, I'm not multiplying the sum by 4. I'm just multiplying the number by 4. That ain't good enough. I want to multiply this sum by 4. That is 4 times the sum of a number. I like it. I like it. I like it. If it doesn't totally make sense yet, it's semi-okay. But you got it. You understand there's a fundamental difference between these two. So this would be 4 times the number, and then that increased by 7. Or 7 more than 4 times the number. That is not 4 times the sum. Let me ask you a slightly different way. What is 4 times the sum of 2 and 6? What do you have to do that problem? I want to know what 4 times the sum of 2 and 6. Try it. Do it right now. 4 times the sum of 2 and 6. Don't say anything out loud. Don't say anything out loud. Staring a few people down.
4 times 2, or what?
Oh yeah, 4 times the sum
Of 2x.
No. 4 times the sum of 2 and 6. There's no variables. There's 4 times the sum of 2 and 6. Beautiful numbers, and that's it. No variables.